10C, welcome back as we continue this wonderful world of factoring. So, two-step factoring is what I want to look at today. Now, if you're anything like me, two-stepping, it's a little ugly. Doesn't matter, I go to a wedding, my wife wants to two-step, it's not fun. However, two-stepping in a classroom, love two-stepping in a classroom because it just means more math. Nothing's new today, it's just knowing when you have to do what. This is the kind of two-stepping I like. So, real quick, we've looked at GCF factoring, we've looked at simple trinomials factoring, and we've looked at complex trinomial factoring using decomp. Let's take a look at the first two questions. Please note that today I'm going to do some add-on questions, and then I'm going to refer to the booklet. So, this isn't in the booklet. Grab a sheet of paper, turn to the back of the booklet, maybe you have some work there. Take these questions down and see if you can factor them. Take a minute or so. Try to factor these, and then we'll talk. Now, of these two, I'm guessing and hoping that when you looked at these and went to factor them, you thought, you know what, I can do both of them. However, I like this first one first because this first one is just a simple trinomial. I have a p squared, a p-value, and a constant. That's the right stuff for simple trinomial factoring. And simple trinomial means we need to multiply to get 18, but we need to add to get -9. So work with that 18 to start with. There are fewer combinations. What can you multiply to get 18? 9 and 2. Well, 9 plus 2 is 11. We need a -9. Positive 18. Well, two negatives make a positive. There's our positive 18 still, but that's -11. Still doesn't help us. What's another combination for 18? Well, there's always that 118. 1 times 18. Wow, we need two negatives though. Two negatives make a positive 18. -1, -18 is -19. Oh, did I forget to put the 1 in there? No, I did not. Don't accuse me of that. I make errors, but not on this one. What else will multiply to give us 18? Don't forget about 6 and 3. -6, -3 is positive 18. -6 plus -3 is -9. There's our combination. And because it's simple trinomial, man, p minus 6, p minus 3, there's the factored form. Our initial trinomial is now a multiplication question. P minus 6 times P minus 3. So that one hopefully wasn't too bad for you. Just got to watch the signs. Now this second question, it's not a simple trinomial. No, that doesn't cut it. Because our x squared has something with it besides a 1x squared. So it's not simple anymore. Now, a lot of you, I'm guessing, have probably jumped into the complex trinomial decomposition. I don't want to review that yet. Technically, I'm not going to do this either on this question. For the last few lessons that we've been doing factoring, I have referred to the fact that we should always be looking for GCF factoring to start. Look to see if you can GCF factor. We have 4x squared, 20x, and 24. Obviously, an x cannot be factored out because there is no x in our last term. But 4, 20, and 24. What's the GCF for those three values? 2's not big enough. Let's factor out a 4. Our GCF, the greatest common factor here is a 4. Always, I've referred to it, and here's why. GCF factoring to start. 4x squared divided by 4 is going to leave us with a 1x squared. 20x divided by 4 leaves us with a 5x. 24 divided by 4 leaves us with a 6. Now, if I just clean this up briefly, I don't need a 1x squared. I can just write this as 4 times x squared plus 5x plus 6. What do you hopefully see at this point? Well, we have the GCF. One of the factors is 4, but the second factor, yeah, now we actually have what's remaining, a simple trinomial, an x squared, a something x, and a 6. All of a sudden, after taking out this GCF of 4, we're left with a trinomial with the right stuff to be a simple trinomial. How do you do a simple trinomial? We want to multiply to the 6, but we want to add to the 5. What multiplies to 6 but adds to 5? 2 and 3. Simple trinomial. There's the factored form, but please don't forget to bring the 4 down. Otherwise, it's not complete. How could I multiply or turn this into a multiplication question? It becomes 4 times x plus 2 times x plus 3, because we did a little fancy footwork and a little bit of two-step factoring. GCF first, simple trinomial second. Nothing new. It's just recognizing to always look for GCF factoring first. Let's try another one. So here's what we just talked about. Always check for GCF first. Check the remaining factors for the right stuff. Can we do simple or a complex trinomial factoring after that? Well, take a look at this 2x squared y plus 14xy minus 60y. Start it, finish it. I'll talk about it. Turn me back on for a video after you've given it a try. So based on what we just talked about, 2x squared y, 14xy minus 60y, what's the GCF in this case? 2, 14, and 60. 2 can be factored out of each. X squared, x, and no x. No x can be part of our GCF, but we have a y, and a y. We can factor out and remove a y from each term. So we're going to do GCF factoring to start, and each of these will divide by 2y. When we divide by 2y, 2 divided by 2 is a 1. We still have an x squared. Y divided by y is gone. 14 divided by 2 is 7. X divided by nothing is x. Y1 divided by y1 is a y0. It disappears. Negative 60 divided by 2 is a negative 30. Y1 divided by y1, subtract exponents, exponent 0, it disappears. There's GCF factoring. Have we factored this question? Technically, we have. This has become a monomial times a trinomial. We have factored it. But you will find, I'm pretty sure every instruction on any assignment will be to fully factor the polynomial. So just because we have turned it into a multiplication question doesn't mean it's finished. And why not? Because we have an x squared, a something x, and a constant. There's our simple trinomial. So now I can factor that. We want to multiply to get negative 30. We want to add to get 7. Multiply to negative 30, add to get 7. What two numbers will multiply to get 30? Well, 3 and 10, and that's going to work to give us 7, but we need a positive 7. Negative 3, positive 10, there's your negative 30 and your positive 7. Keep the 2y, that's one of the factors. But the other factors now, x minus 3 times x plus 10, and that's all we need to be fully factored. Because it's a simple trinomial, Factors quick and easy if you know your basic facts. So look for GCF first. Look for a trinomial that's factorable second. You won't always have two steps, but you need to look for it. Page 43 in the booklet. Question B. Pause, give it a try, and then we'll talk. All right, let's talk. Always check for GCF first. We have no variables common to all of them. So GCF, no variables. What's going to divide into 3, 13, and 10? The only thing that will divide into 3, 13, and 10 is a 1. GCF of 1 doesn't happen at this point. GCF of 1 is only useful when we're partway through decomp solving. So at this point, there is no GCF. What do we have? We have a something x squared with an x term with a constant. This time, because the x squared's not by itself, we have complex trinomial and the decomposition process from the last video. Here we go with decomp then. A times 3. 3 times negative 10 is negative 30. So we need two numbers that multiply to negative 30 but add to negative 13. What's going to multiply to negative 30 but add to negative 13? So sometimes you got to play around a bit. Some people see it, some people don't. Negative 30 and 13. What about positive 2, negative 15? Multiplies to negative 30, adds to negative 13. So if you recall from the other video on decomp, we decompose that middle term using the two numbers we found. So we still have the 3x squared, but now we have plus 2x minus 15x minus 10. Negative 13 has been broken down to 2x and minus 15x. Pair up our four terms and GCF each term. So 3x squared and 2x. GCF, we can factor an x out of each. Leaves us with 3x plus 2. Negative 15x and a negative 10. Well, they're both negative. And again, that's sometimes a hint to tell us we have to factor out a negative value. Two negatives means factor out a negative. What's the GCF? Well, negative 5 is your GCF. So we're going to factor out a negative 5. Negative 15 divided by negative 5 is a positive 3x. Negative 10 divided by negative 5 is positive 2. And what's good? That what we have in our brackets is the same, and that's our first factor. And that is multiplying by the x minus 5. So in this case, not a two-stepper, it was just no GCF, but a complex trinomial. You need to learn to recognize and understand what kind of factoring is going to occur in each question. Page 43, F. Again, I'll give you a hint. It's a two-stepper. I believe it even says in there, GCF first. Now, even though this particular question says GCF first, okay, that's a big hint that it's going to be a two-stepper. You will not get that on an assessment. You will get that on an assessment. 6x squared minus 21x plus 9, and it'll say fully factor. So give it a try, and then we'll talk. 6x squared minus 21x plus 9, check for your GCF. In this case, our GCF, there's no x common to everything, but 6, 21, and 9, know your basic facts. We can factor out a 3 from each of these terms. So our first step will leave us with a 3, and then a 2x squared minus 7x plus 3. GCF of 3. Now what we have remaining, 2x squared, negative 7x, and a 3. X squared isn't by itself, but we have the right stuff for a complex trinomial. So we can't, well, we could stop at this point. We have factored it, but we need to fully factor the questions. So now we do decomp. 2 times 3 is 6. So we need to multiply to get 6, but we need to add to get negative 7. Like we've been doing all along with the decomp. What can we multiply to get 6 but add to get negative 7? What about negative 1, negative 6? That actually will work kind of nice. Negative 1 times negative 6 is 6. Negative 1 plus negative 6, there's your negative 7. So keep the 3 out front. Sometimes, I'll be honest with you, I'm going to do it a little different. I'm just going to remember that this 3 needs to be in my final answer, and now I can just work with my trinomial. But don't forget the 3 in your final factored form, because it is a factor. It needs to be in your final answer. So what did we discover? We still have 2x squared, but negative 7x is going to become a negative 1x minus 6x plus 3. Pair them up and GCF each. What will 2x squared and a negative 1x factor out? Well, an x will factor out. That'll leave us with 2x minus 1. Negative 6x plus 3. Well, what can I factor out from a 6 and a 3? Well, that would be a 2. So if I divide each by 2, I'm left with, sorry, not 2, my bad, a 3. Nah, I was already doing the division. We are dividing by a 3, factor out a 3. So if I factor out a 3, I'm left with negative 6 divided by 3, which is a negative 2x. But right away, I see I have a positive 2x and a negative 2x. I like that they're both 2x's, but different signs. What does it tell us? Well, that tells us that instead of factoring out a positive 3, let's factor out a negative 3. Because negative 6 divided by negative 3 is now a positive 2x. 3 divided by negative 3 is now a negative 1. And look at that. 2x minus 1 and a 2x minus 1. So there's the second factor along with this 3 that we factored out earlier. And it has to multiply by the x minus 3. Fully factored form. There you go. Today's lesson, nothing new. It's just understanding that sometimes you need to look for that GCF. Well, not sometimes. Every time you need to look for the GCF factoring first. Sometimes it'll happen and you're going to do some fancy two-step in work. Two-step factoring. But sometimes there won't be a GCF and it'll just be trinomial factoring. So, assignment, booklet, page 43. Please omit K and 11. You don't have to worry about those. Those of you who want a little extra practice, you're bored sitting around the house, you say, hey, you know what? A little more practice wouldn't hurt. Our booklet at the end has all kinds of questions. Remember, the very back of the booklet has answers for that stuff. So, get some work done. Learn it, live it, love it. Have a great day, folks.